Hello dear student, this is topic 2nd from unit 1st, molecular spectroscopy. Molecular spectroscopy. Now, spectra means spectrum of light, spectrum of energy. Scopy, है ना, microscope तुम्ही ऐकलं असेल कधी. So scopy, to observe. Okay, so spectroscopy. So what happens? Spectroscopy is the study of interaction of matter with the electromagnetic radiation. Interaction of matter with electromagnetic radiation. Okay, so when any radiation falls on a molecule or atom, the part of that radiation or energy is absorbed and remaining is transmitted. The absorbed radiation by the molecule is used to perform different type of motion. What different type of motion takes place over there? There may be the electronic transition, there may be the vibration in the molecule, there may be the rotation of the molecule. These are different processes happens with the molecule. Okay, so this technique is useful to determine the structure of molecule, and also this is useful for determining the concentration of any solution. Okay, so that's why this technique is very important. Using this technique, we can find out different pollutants present in the air, water, and soil also. Okay, or we can find out some impurities from different substances. So that's why this technique or the spectroscopic technique is having its own importance in our day-to-day life. So what is electromagnetic radiation? These are the radiation propagate in the form of transverse wave. It propagates in the form of transverse wave. Okay, they involve oscillating electric and magnetic field which are perpendicular to each other. Which fields are there? Oscillating electric field is there and oscillating magnetic field is there. So these two fields are perpendicular to each others. Okay, and they are traveling in a same direction. Okay, or in the direction of propagation of wave. Okay, so there are three important properties of any wave. Okay, that is a wavelength, another is a frequency, and third one is a wave number. What is the wavelength? The distance between two consecutive troughs or crest. So this is the crest. The distance between these two crests, okay, or distance between these two troughs is called as a wavelength. Wavelength, and it is expressed in terms of nanometer, as angstrom, as a micron, or as a millimicron. Okay, 1 nanometer is equal to 10 raised to 9 meter. 1 angstrom is equal to 10 raised to 10 minus 10 meter. 1 micron is equal to 10 raised to minus 6 meter. 1 millimicron is equal to 10 raised to minus micron. Okay, these are the things over there. These are the important properties of the waves. Okay, and how? See, second property is a frequency. What is the frequency? The number of waves cross a given point in a second. Number of waves cross a given point in a second. It is given by equation in mu is equal to c upon lambda. Mu is equal to c upon lambda. Okay, nu. I am talking nu. I'm talking about. Okay, not the mu. This symbol is called nu. Okay, so this is n. I'm just indicating you the initial. So where c is the velocity of light, that is 3 into 10 raised to 8 meter per second. Frequency expressed in terms of hertz, has its a unit per second. 1 hertz is equal to the 1 vibration per second, or 1 oscillation per second. Okay, 1 hertz is equal to 1 vibration per second or 1 oscillation per second. So what is the wave number? What is a wave number? So it is a number of wave in a 1 meter distance. number of waves in a 1 meter distance. It is given by relation nu bar is equal to 1 upon lambda. Okay, nu bar has unit per meter. But however, in spectroscopy, wave number are commonly referred to the number of waves in 1 centimeter. Okay, in spectroscopy, we are considering especially 1 centimeter distance to express the wave number. Okay, so mu is equal to c upon lambda, that is equal to c into nu bar. Nu equal to c upon lambda is equal to c into nu bar. Okay, so electromagnetic, what is electromagnetic spectrum? That electromagnetic spectrum are having different bands, different regions. Okay, what regions are there? Gamma ray, X-ray, vacuum ultraviolet, ultraviolet, visible, near IR, mid IR, far IR region, infrared IR stands for, and microwave and radio waves. These radio waves we are using for mobile phones, TVs, and all. Microwave we are using to heat the food. Okay, then visible region. So in this region we can see the things आपल्याला जे दिसतं ते ह्या रेंज मध्येच दिसतं. जेव्हा वेव्हलेंथ लाईटची ह्या रेंज मध्ये असेल 380 ते 780 तेव्हा आपल्याला आजूबाजूला दिसू शकतं. ओके, देन अल्ट्राव्हायोलेट इज दॅट. एक्सरे तुम्हाला माहिती आहे आपल्या बोनच्या मध्ये जे काही फ्रॅक्चर वगैरे असतील त्याच्यासाठी त्याचा डिटेक्शन साठी उपयोग होतो. आणि गॅमा रेज आर हॅव्हिंग इट्स their own importance. Okay, this is what the electromagnetic spectrum. Okay, now see, from this to this direction wavelength increases, means the radio waves are having highest wavelength and cosmic rays are having lowest wavelength. Frequency, radio waves have a higher frequency while the cosmic rays have lower frequency, and cosmic rays are having higher energy while radio waves have lower energy. And this is our area of interest. Okay, so here this is workable for us की आपल्याला जे दिसतं जे ज्या आपल्या ऍक्टिव्हिटी चालतात दिवसा किंवा काय असेल त्या ह्या दिस इज ड्यू टू द दिस रिजन 380 ते 780 नॅनोमीटर. ओके, आणि बाकी जे काही आपण स्टडी करतो है ना, फोन वगैरे टीव्ही वगैरे ह्याच्यासाठी हा रिजन महत्वाचा आहे, मी सांगितलं तुम्हाला. नाव what things happen when any electromagnetic radiation fall upon a molecule or atom? What happens? The transition of electron from lower energy electronic level to higher energy electronic level. This is one thing. Then vibration of constituent atom in a molecule about the mean position, and rotation of a whole molecule about an axis. So total energy, how it can be calculated? The whatever total energy given by any electromagnetic radiation to a molecule is equal to the electronic transition, E vibrational plus E rotational. Okay, so absorption of energy is explained by using the Planck's quantum theory of radiation. Planck's quantum theory of radiation. The process associated with important region of electromagnetic radiation. What happens in UV region? There is a transition of electron from ground state to excited state or lower energy state to higher energy electronic level. Okay, near infrared region or mid infrared region, the vibration of constituent atom about their mean position takes place. Okay, and in far IR or far infrared region, rotation of molecule about an axis takes place. Okay, so what Planck's equation is? What is the quantization of energies? What Planck says, the energy transfer in the form of quanta having its energy h nu, having its energy h nu. Okay, so h is a Planck's constant, its value is 6.625 into 10 raised to minus 34, and nu is the frequency of radiation expressed in per second or hertz. So E is equal to h nu, or you can write E is equal to hc upon lambda, or even you can write E is equal to hc nu bar, hc nu bar. So this is one example. What is that? They are giving you the wavelength of radiation. Okay, and from which you have to find out the frequency, okay, then wave number and the energy associated with that radiation. So what lambda is equal to 525 nanometer, that is equal to 525 into 10 raised to minus 9 meter. Okay, now what we are going to see first is a frequency. What is the frequency? C upon lambda. Okay, so what is the speed of light? It's a 3 into 10 raised to 8 meter per second, and wavelength is a 525 into 10 raised to minus 9 meter. Meter get cancelled. So this much of the hertz, this much of the hertz is the frequency of that radiation. Okay. Now mu bar is a wave number 1 upon lambda is 1.9 into 10 raised to 6 per meter, and energy is equal to h nu, that is given by this one. Okay, this is what example for above concept. Okay, so whatever explain over here, you just try to listen the lectures again and again. If any query comes, please contact me with the WhatsApp group. Okay, so remaining part I am going to continue in the next lecture. Thank you.